Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good evening, students. I promised, I'm gonna be producing a video on for the example question that I have given earlier today, because I think that's what many of you are expecting. It's just that I have to apologize because this is my first time trying to record with my phone. And I think the recording at night is giving these extra shadows of my hand. Okay, so let's just go through this. So this is basically an example of application in linear programming. So in this question, you step number 1. Okay, so basically we need to collect the important information. So this question is about an investment where the investor has 60,000. So we have $60,000 to be invested in the basically two portfolios. So we have number one is the CD. Oops. And we have a mutual fund. Okay, a mutual fund. And we know that the CD gives 5% annual return, and the mutual fund yields average of 9%. So the mutual fund, so these are all the additional information that we have. A mutual fund requires a minimum of 10,000. And the investor requires that twice as much should be invested in CDs. Okay, so basically CDs equals twice, 2 times the mutual fund. Okay, so how much should be invested in CDs and how much in the mutual fund to maximize the return? Okay, so from this information we can basically sum them up. So we know that we have, this is our objective function. We want to maximize the return. So our return, okay, is given by this information. So we have, so let's just, first of all, I'm going to put this. So CD, I'm going to use X, and for mutual fund, I'm going to use Y. Okay, so we have maximize return. So where the return is now given by this equation, we have, so 5% is 0.05x plus 0.09y. So this is our objective function. And these are all our constraints. So we want to maximize this, but at the same time, we have to make sure that we fulfill all these criteria. We cannot violate any of these criteria. So subject to, so we have the first constraint would be, so X. So X is the amount of money that we invest in CD, plus Y. The amount of money that we invest in a mutual fund must be less than or equal to 60,000, because this is the amount of money that we have. So we cannot invest more than that, but we can invest less, but that is of course not efficient. So this is our first constraint. Second constraint would be the required minimum. So we know that Y must be greater than or equal to 10,000, cannot be less than 10,000. And then we have the last criteria, the last constraint. So this is the second constraint. The last constraint would be the preference by the investor, where X, okay, must be, so always check back the question, the word used. So you have to be make sure you familiarize with the English word. So here the investor require that twice as much should be invested in CDs as in the mutual fund. So the amount of money put in the CD, okay, X must be greater than or equal to 2Y. Okay, so this is the third constraint. Okay. So this is next, step number 2 would be, so we have already formed the mathematical problem. So this would be step number 2, okay, where we convert all the information given in the question into a formal mathematical, okay, statement. And then step number 3 will be we have to convert all this into graph. So we have 3 constraints. So from these 3 constraints, just draw a graph here. So if this is and of course we know the complementary slackness is that x must be greater than 0, y must be greater than 0. Okay, we cannot invest less. So if we were to draw, so if this is y and this is x, so we have 3 equations. So let's come up with the first constraint, x plus y 60,000. So how do we simplify this? So we can change this. So this means y equals 60,000 minus x. Okay, so we have let me just try my best here, 60,000, and we have here 60,000. Okay, connect these two. So this would be equation 1. What about the second equation here? So we have y must be greater than 10,000. So this is simply a straight line. So if this is 10,000, so we have a straight line here. So this is equation 2, constraint number 2. And then the last constraint here, okay, so here this means basically we have, if you were to transform this, we have 2y equals x. So y equals half of x. So here we have so if y equals so the origin would be included in the equation here, because when y is 0, x would be 0. So what happens when the value of x is let's say 2? When x is 2 or 20,000, y would be 10,000. So when y equals to 10,000, we have 20,000 here. So this, so we have 2 lines here, connect them. So this would be the third line. Okay, so now we have already drawn, okay, the all the constraints. Now we need to identify the feasible region, So now let's have a look at the first. So this is basically we are repeating what we have discussed in 5.1 and 5.2. Okay, section 5.1 and 5.2, where you need to identify which region. For example, from this equation 1, we have basically divided the plane into 2. Okay, above and below. So which part of this of this region, okay, above or below, that satisfy this constraint? Okay, so pick up any point. So easiest point would be to pick up the origin, because the origin would be located in the below area, this region. So 0 and 0, so when we put 0 and 0, 0 and 0 here, 0 plus 0, is 0 plus 0 less than or equal to 60,000? Yes, so we know that this region is the region that satisfies the constraint, okay, for equation 1. Now repeat, what about equation 2? Equation 2 is y greater than 10,000. So you know that any region above this line would be satisfying all the points here. The region above the line would be the one that solve the problem. And last but not least, for the third graph, the third equation, we have x must be greater than or equal to 2y. Okay, so here we have above and below. Okay, cannot use 0 and 0 because that one is exactly on the border point, on the borderline. So let's pick up maybe this one. Okay, this is 0, 10,000. 0 and 10,000. So when x is 0, okay, and y would be 10,000. Okay, this point. So 0, is 0 greater than or equal to 2 multiplied with 10,000, 20,000? No. So we know that the region above here, okay, violates the constraint. So we know that the opposite, the region below the third line, would be the one that fulfill the criteria, the constraint. So look at the region where all the basically the three shades or patterns intersect, okay, or like what you said, bersinggung, okay, the one that basically overlap on each other. So that will be indicated by this triangle here. Okay, this triangle. So we know that this triangle Okay, what is this triangle? It is the triangle that basically fulfill all these constraints, and we know that we have three corner points. Okay, three corner points. So corner points, corner A, B, and C. Okay, so what we need to do next is to find the coordinates. Okay, the coordinates of the these corner points. So this is basically step number 3. I forgot to mention that earlier. Okay, step number 3. Now this triangle, so what is the coordinate for A? Okay, for A is, so this is 20,000 and 10,000. What about B? The coordinate. Okay, B would be a bit require some additional steps because it is the intersection between equation 1 and equation 3. So what we can do is that we can simply substitute, okay, equation 1 and equation 3. So if we have this equation, y equals to 60,000, okay, 60,000 minus x. So, and from the third equation we know, so we have, so this is from 1, and from 3 we know 2y equals x, right? So this is from the third equation. So replace this. So we know that y equals 60,000 minus 2y. So bring to the other side, 3y equals to 60,000. So we know that y equals 20,000. Okay, when y equals 20,000, what is the value of x? X equals 10,000. Sorry, x equals 40,000. So we know that this is 40,000 and this is this is 40,000 and this is 20,000. Okay, so now we got the coordinate for B, which is 40,000 and 20,000. What about C? Now, C would be the intersection between line 1 and line 2. So we have y equals to 10,000. So we know y is 10,000. What is the value of x? So x would be, so when y is 10,000, x would be 50,000, right? 60,000 minus 50,000 give us 10,000. So this is 50,000. So we have 50,000. Okay, so now that we have these three, okay, our corner points. Now, what is the meaning of this corner point? These corner points are potential candidate that will give us the maximum revenue, the maximum return. However, to do that, we need to investigate them one by one. So what we need to do is that for step number 4, we need to basically plug or sub these values into the objective function. Now, what is our objective function? Our objective function would be given by this. Okay, this original function. So we have let's do this here. So 20,000. So A, B, and C. So let me I'm just gonna remove those 1,000 just to make the calculation I think much not messy. So we have 50 and 10. Okay, so now plug this in 0.05 x plus 0.09 y. Okay, so we're gonna have, so this will be 0.05 multiplied by 20 plus 0.09 10, 0.05 40 plus 0.09 20, 0.05 50 plus 0.09 10. Okay, so this, so now use your calculator and this will give you basically this is 1,150, this is 3,800, and this will give you 3,400. Okay, now when we compare these three, which one will give us the maximum value, the highest return? This one. Okay, so step number 5, then we simply say that we need to interpret. Okay, so to get maximum return, need to invest how much? 40. Okay, so $40,000. Don't forget the thousand. I mean, like of course during working you can use shortcut and stuff, but when you are writing the conclusion, the final answer, do not make a simple mistake here. So 40,000 in CD and $20,000 in the mutual fund. Okay, and to maximize return. And also the question asks, what is the maximum return? The maximum return is 3,800,000. Okay, so that's basically the 5 steps that you need to do in order to solve an application of linear programming. Okay,